Namaste everyone. Think about playing cricket or following traffic rules. Math also has important rules or properties for rational numbers. Understanding them is like knowing a gully shortcut during traffic. They make calculations faster and simpler. In this first part, we will uncover the powerful properties with math examples and real life connections. We will start with closure property and commutative property. Later, in part 2, we will explore associative property and distributive property. First, we have the closure property. This property checks if performing an operation on two rational numbers will always result in another rational number. Addition 1 by 2 plus 3 by 4. If we take the LCM 4, we have 2 plus 3 divided by 4, which gives us 5 by 4. Is this a rational number? Yes. 5 by 4 is still in the club. We can think about this as mixing colors. If we mix two liquid watercolors like blue and yellow, you get another liquid watercolor that is green. So it stays in the watercolor category. So rational numbers are closed under addition. Coming to subtraction. Out of 5 candies, if someone takes 2 candies, you are left with 3. And that 3 is a rational number. Let's look at another example. 1 by 3 minus 1 by 2 equals to 2 minus 3 divided by 6, which gives us negative 1 by 6. And that is still rational. So you stay in the club. So rational numbers are closed under subtraction. Multiplication. 2 by 3 multiplied by 1 by 2 gives us 2 by 6. And if we simplify that, we get 1 by 3. Welcome 1 by 3, you are rational too. So rational numbers are closed under multiplication. Division. 2 divided by 3 equals 2/3. Still in the club. But wait, what about 5 divided by 0? This is undefined. It is like trying to share 5 laddus among 0 people. It just doesn't make sense. The result is not a rational number. It's not even a defined number. So we got kicked out of the club in this case. Since there's this critical exception, rational numbers are not closed under division. Next, the commutative property. The commutative property asks if we swap the order of the numbers in an operation, does the answer stay the same? Think of commuting as changing places. Addition. Let's try with fractions. 1 by 2 plus 1 by 4. To add these, we find a common denominator. So 2 plus 1 whole divided by 4 equals 3 by 4. Now what if we swap them? 1 by 4 plus 1 by 2 equals 1 plus 2 whole divided by 4, and that gives us 3 by 4. Same answer. Just like paying a shopkeeper first 20 rupees and then 10 rupees gives the same total as first paying 10 and then 20. The order doesn't matter for the total amount, even with fractions. So addition of rational numbers is commutative. Subtraction. Consider 3 by 5 minus 1 by 5. This equals 2 by 5. But if we swap them, 1 by 5 minus 3 by 5 gives negative 2 by 5, and that is different. Putting on your socks and then shoes is not the same as other way round. Order matters critically here. So, subtraction of rational numbers is not commutative. Coming to multiplication section, we have 2 by 3 multiplied by 3 by 4. Multiplying the numerators and the denominators gives us 6 by 12, which simplifies to 1 by 2. Now let's swap them. 3 by 4 multiplied by 2 by 3 equals 6 by 12, which also simplifies to 1 by 2. Same again. So, multiplication of rational numbers is commutative. Coming to division, let's look at 1 by 2 divided by 1 by 4. This is the same as 1 by 2 multiplied by 4 by 1, which equals 2. But if we swap them, 1 by 4 divided by 1 by 2, this is 1 by 4 multiplied by 2 by 1, which equals 1 by 2, not the same. You can think of this as sharing 6 samosas among 2 friends. Each gets 3, but sharing 2 samosas among 6 friends, then each gets 1/3 of the samosa. So order matters over here. Division of rational numbers is not commutative. Let's do a quick recap. In the closure property, we discovered that rational numbers are closed under addition, subtraction, and multiplication. But division works only if we are not dividing by 0. Commutative means changing the order. It works for addition and multiplication, but not for subtraction and division. That's it for part 1. Join us in part 2, where we will explore the associative and distributive properties along with identity and inverse elements for rational numbers.